Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we are Group 6 from Section 2 for Computer Architecture Organization. We want to present about our project. The task is illustrate and simulate on pipeline concept, hazard or branch delay. Okay. Okay. First of all, I want to introduce our group members. First is Muhammad Faiz bin Hamidun. The metric number is DE20024. And then is me is Muhammad Akram bin Muhammad Idris DE20030. And the last one is Muhammad Shamil bin Abdul Hadi Okemi. The metric number is DE20035. Okay. Next, for the introduction. Okay. For the introduction is the pipelining is a technique that helps computer runs faster and more efficiently. So it breaks down tasks into a smaller parts and processor them together. So that each part has a specific job to do, but there are some risks with pipelining. Some tasks depends on each other and can cause unexpected problems. Okay, and then the sharing resources can also slow things. And when multiple tasks try to write data at the same time, it can create conflict and errors. Okay. So another challenge is dealing with instruction that depends on uncertain condition. This can slow down the process and waste resources. So to handle this, there are techniques like predicting what will happen and arranging tasks to make things smoother. So to design the better computer, it's important to understand pipelining, the risks involved, and how to manage them. This helps make sure everything runs smoothly and efficiently. Okay, next, for the objective. Okay. For the objective is to illustrate the concept of pipeline hazard using RIP software, and then analyze the impact on pipeline throughput, and then to get a better understand how five-stage RIP processes work. Okay. Next, for the methodology. Okay. So for the methodology, the literary review focus on a simulation to score RIPs we should use in the field of computer architecture. RIPs provide a comprehensive environment for building, implementing, and analyzing instruction set architecture. This paper summarizes the key features of RIPs, its practical application, and recent advancement. It also highlights the tools division in computer architecture research and instruction. Okay, that is all from me. Thank you.
Hello and Assalamualaikum. My name is Muhammad Shamil bin Abdul Hadi and my matrix number is DE2005. So we are from Group 6 Session 2 going to illustrate and simulate about the 5-stage RISC processor using RIP software. So in this RIP software we are going to use 5-stage processor. So this is how the processor will look like. In this processor, this is the instruction fetch, this is the instruction decode, this is the instruction execute, this is the memory access, and the last one is the write back. So in each stage there are different function. So this is our assembly code. As you can see here, we are going to use load instruction, some arithmetic operation, store instruction, and the last one is load instruction. The difference between this and this is we load from memory, and this one we load from the immediate value. So as you can see here, the value in we are going to use A0, A1, register A0, A1. As you can see here, the register at A0, A1 and A2 0, right? So the value in cache is also 0. The value in memory, if you want to see the memory address is as you can see here, this memory address store the value at here for this one, because the global pointer points at the memory address. So let's see what happened if we do all 5 steps at this instruction, at the load instruction. What we expect here is that in register A0 and A1 will be the 6 and 7. So as you can see here, after all five stage instruction, after all five stage has been processed at this instruction, the value in the register will change. That's why there's different in this register. Let me see. In case it will save the memory value, which is 6 and 7 in memory. There is nothing different. There's nothing happen. So in the pipeline, as you can see here, after the loop instruction have finished, we can see some hazard here because this instruction depends on this data. So how to avoid this? We are going to use NOP instruction. Okay, so that's what happened after the 8 cycle. So let's see what happened after the full instruction has been through 5 stage. As you can see here, the value at A0 has changed to 13 because we do the arithmetic operation. The value in A1 has changed to 91 because we multiply, and the value at A2 is 104 because we add. So what we expect is the value of A2 will be stored in the memory. So this is the value in hexadecimal. So if we convert 104 to hexadecimal, we got this. So what happened in cache? This is will become 0. And what happened to our pipeline? So what will happen to our pipeline is, as you can see here, there is hazard after the load instruction because this instruction depends on this. So which means the register not ready. So this one also has hazard because we want to end the instruction. So at here we can also see the execution info. There are information for cycle, instruction, retired CPI and IPC. So how do we get IPC? CPI is we divided cycles with instruction which we will get 1.64, and IPC we divided 11 with 18 and we will get 0.611. Okay, so let me show you what happened if I add NOP instruction. Okay, let's see the difference. So as you can see here, there is no more hazard after the load instruction. The NOP did not do anything for the instruction, so it will allow the instruction to be ready. So the difference between without NOP is the instruction retired has been increased to 12. So the value for CPI and IPC will also change, which is the value for CPI is 1.5 and the value for IPC is 0.667. So which means the processor with NOP is better because it will have more instruction per cycle. Okay, that's all for me. Thank you.
Assalamualaikum, my name is Muhammad Faiz Muhammad. My trade number is DA20024. And today I want to explain about our discussion. For this project, we are going to use a web software as a simulation tool to see the process of the CPU and pipeline system. So in this system, we use 5 stages, which is for the first stage is fetch stage. In the first stage, instruction is being fetched from the memory, and then we go for the decode stage. From the decode stage, we decode the instruction and fetch the source of operand, and then we go to execute stage, and then to memory stage, and the last is a write back stage. For example, LWAO num1 is one of our learn instruction that will be used for our assembly program. Number 1, IF, instruction fetch. Fetch the instruction LW A0 num1 from memory. And then ID, instruction decode. Decode the instruction and identify the load operation LW and the register involved A0 and num1. And then execute, access memory and load the value from the memory address num1 into register A0. And then go to the memory, retrieve the value from memory and forward it to the next stage. And the last stage is write back. Write the loaded value to register A0. So this is the diagram, the example of diagram for the whole process. So we have instruction fetch, instruction decode, execute, memory and write back. And this is the example of the table for instruction. So this is instruction line, step 1, step 2, step 3, step 4, step 5, step 6, and step 7. So this is the RISC pipeline example with 3 instructions and 7 clock cycle. Then we go to the conclusion, and for the conclusion, our team successfully modeled pipeline hazard. We investigate technique to reduce branch delay and gain insight into the influence on pipeline throughput through realistic simulation and analysis. Our knowledge of pipeline processes and optimization strategies has improved as a result of the study. I think that's all from me. Thank you.